That's our business proposition.
Yeah.
And so I'd like to say, yeah, we do see a need for it.
Welcome to the Coles Ventures Podcast.
Thanks for hopping on and taking time out of your busy day to come chat with me.
Love it.
And then
happy to be here.
We'll just run through. Why don't you introduce yourself and say what you're working on, what you're doing, why you're here, all that.
Well, I'm here because of Sky Henderson. We all know that's true.
Yes. Is that how you got introed to fuel?
Yeah.
I was trying to remember that this morning and I couldn't remember how exactly you got placed into our co-working space.
Yeah. I met Sky at an event and he said he was starting up this co-working space.
Yep.
I was in an office by myself. It was great. It was a nice office.
Yeah.
Nothing ever happened.
Yeah.
And I was getting a little lonely. So
yeah,
it's a great space to be in. Yeah. I'm Tyson Schlect, been in infrastructure for my whole career. By that, I mean power and water infrastructure. And came to fuel pretty early on and came here in connection with helping build a startup company called INFRA Science and Engineering.
Okay.
Which we can talk about a little bit.
Yeah.
We're in our, I've been on board for a little over a year.
Okay.
And the company's about 2.5 years old.
Okay. I did not know that was so young and that you joined like just not that long ago.
Yeah. Yeah.
That's pretty crazy.
Our founder, his name is Kyle Cotton, great guy over in Coeur d'Alene.
Nice.
He was doing some work in advance of me coming on board and then, about a little over a year ago, came on board and have been growing quite a lot since then.
Okay. Nice. That's awesome. And you said it's based out of Coeur d'Alene, correct?
Yeah, we have an office in Coeur d'Alene.
Nice.
We've got 5 or 6 staff that work typically out of Coeur d'Alene.
Yeah.
I'm here. We've got a couple in Texas, 3 in Chicago, a couple in North Carolina.
Okay. But the hub is Coeur d'Alene.
The hub is right here.
It's right,
The hub is right here in
you are the hub.
Fuel Co. No, I would say that the hub is in Coeur d'Alene.
Okay, nice. Yeah. Is he from Coeur d'Alene? Why would he start it there versus anywhere else?
Yeah.
Okay.
He's from Coeur d'Alene.
Nice. That's cool.
Yeah, he's from Colorado originally.
Okay.
I was born in Bellingham.
No way.
Yeah.
I did not know that. That's cool.
Born in Bellingham. Actually, I was born in Seattle in Swedish Hospital.
Okay.
And then my parents lived in Bellingham. My dad worked for Puget Power.
Okay.
And then he decided to take a job with what was then the Washington Water Power Company.
Okay. Yeah.
And so came over to Spokane when I was 2.
Yeah.
Grew up here, went away for a little bit, and now I'm back.
Yeah, that's awesome. So you come from a long line of engineers then. As you said, your grandfather was engineer, father, and then now you. Yeah.
So great-grandparents grew fruit in Yakima.
Okay.
And then farming in the other side of my family as well. And then, my grandpa was the first non-farmer in the family.
Okay.
Went to Washington State College.
Yeah.
Met my grandmother at Washington State College. And then he got a civil engineering degree in 1957, I think. My dad got an electrical engineering degree from Washington State. My uncle got a civil engineering degree from Washington State. So I went and got an engineering degree from Washington State.
Why not?
Yeah.
Why not? When you guys come together, do you guys just like nerd out over engineering stuff?
Actually, yes.
Yeah.
A lot.
I mean, yeah, that's kind of cool.
Yeah. Yeah, I get to talk with my grandpa about some of the glory days of the DOT.
Okay.
When they really built out the interstate system.
Yeah.
It's very analogous in many ways to the trends we're seeing now in power and water infrastructure. Just a paradigmatic distinction in the amount of demand on the system and the sort of the new resources we're tapping into. And so it's fun to put that in action. But yeah, he's got some great stories.
That's awesome.
Running freeway through ground that never had freeway before.
That's pretty sweet. I'm sure there's limited people that you can probably talk in detail about what you do. I'm sure most people are like, oh, I work in infrastructure for like water and power and environmental, blah, blah, blah. And they're like, oh, that's cool. And like, that's probably the end of it for most people. So it's gotta be kind of fun to like, just go into the nitty gritty with some people.
Oh yeah. It's great. Yeah. Family gatherings are a ton of fun in that respect.
That's super cool. Well, okay. So let's jump back a little bit. So you also went to Wazoo, not the Washington State College.
Not Washington State College. I went to Washington State University. Yeah.
That's awesome. Okay. Started there. And then what did we do from there? first jobs. I saw you intern for Avista a couple summers. That's pretty cool. Hands-on stuff.
Yeah, and actually, I was in the utility industry before that even.
Okay.
And so I actually worked grounds crew for Vera Water and Power out in
Oh,
Spokane
that's right.
Valley.
That's right.
And it's funny, that's actually top of mind right now because yesterday at 1 p.m., we got home and we had no water in our house on the South Hill. And the city of Spokane had a truck rolled up 2 blocks down. Turns out there had been a geyser of a leak.
Oh my gosh.
And so they had to get a crew on Sunday, which they did. They found a foreman and 3 other guys to come show up on a Sunday. They got there around 3 o'clock. They were still lights ablazing, digging out that leak at 10:30 when I went and took a look. PM.
Yeah.
And I had chatted with them a little bit on the side of the hole, but it was very similar to stuff I saw at Vera because I used to do flagging for the water crew, and they'd get a call on 2 p.m. on a Friday, and there's a geyser someplace, and it's like this thing snaps in the crew's head. It's like this is go time. We are saving the day.
Yeah.
We are doing high focus Friday energy right here, and fixing this leak. And,
Awesome.
and so they got to dig up the hole and find the leak. It's a mess. South Hill's full of rock, but they made it happen last night, and it was impressive. They came out and made it happen late into the darkness.
Yeah.
But yeah, that's what I did at Vera. Got to work with power crews, water crews, and then during school ended up working summers for Avista. Did asset management.
Nice.
Great experience. I love that company. Love Spokane. And then from there, ended up graduating with a civil engineering degree. And with all of the family history at Washington State University, it was a bit of a conversation to let them know that I was thinking about grad school at the U. And so, I was going to go to law school, decided not to do that for a variety of reasons.
Yeah.
My wife, who was then my fiance, told me, I don't think you're going to be able to live with yourself if you don't go back to school for something.
Sure.
And so I went and got a master's in environmental chemistry and microbiology at the University of Washington in Seattle.
Okay. Easy.
We lived over there. Yeah. Oh, wow.
That sounds incredibly difficult and complicated.
It was hard.
Yeah. That does not sound easy at all.
It was hard. The commute was also hard. We lived way up in Bothell. That's where we could afford to live. And so I know people who do that every day.
Yeah.
Great reason to live in Spokane.
That's true. I know we just went, not just, but in July, I went over for a work trip, and on the map, I had no idea where Bothell really was, but on the map, it doesn't look that far from like downtown Seattle. And it was probably a third of the cost of an Airbnb up there. And so I thought, okay, I'll just drive down. It'll be like 15, 20 minutes. Easy. Not a problem. No, it took me like an hour each way.
Yeah.
It's not close. Like it's far. And so that was just to downtown. So I mean, considering if you're going, I guess to the U would probably be a little bit closer than downtown. But
yeah, it was about an hour on the way in, hour and a half on the way back.
It's crazy.
Yeah.
But anyway,
But I actually loved it in a way. Bus drivers are I love talking to bus drivers.
Really?
If I ride STA sometimes just for fun.
Yeah.
Because I like riding the
just
bus.
chatting them up.
Bus drivers are great. I love bus drivers.
I'm sure they see some wild stuff and have some crazy stories.
They see wild stuff. They ask good questions. They're interested in pretty much everything.
What's going on?
So yeah, great example actually in many ways.
Yeah.
But yeah, I came out of there and my faculty advisor at the University of Washington, just incredible faculty over there, was essentially an industry leader in nutrient removal, which is the removal of nitrogen and phosphorus from wastewater.
Oh.
You don't want too much nitrogen and phosphorus in the rivers because it produces algal blooms. And so that was essentially my area of focus coming out of grad school, and then went into wastewater treatment process design for the whole first decade of my career.
Okay. Nice. What does that entail? Wastewater treatment design. Oh, actually, let's back up a little bit because before people, cause I also get confused. So you were a civil engineering major. Is that correct?
Civil engineering, for undergraduate.
So what is that in like plain layman's terms? Civil engineering entails?
Sometimes simplified as dirt, rocks, and concrete.
Dirt, rocks, and concrete. So it's civil, structural, and mechanical. Is that correct?
Yeah. And other kinds of
the
engineering. I mean, there's
big three.
chemical, electrical, but yeah,
Chemical,
civil,
electrical.
mechanical, electrical.
Goodness. All sorts of
And
crazy stuff.
civil is pretty broad.
Yeah.
You can do a number of different specialties. I was in classes, and most of my classmates really loved the ASCE steel manual, which is where you look at structures. And I had basically no interest in it.
Yeah.
And I loved the carbonate system, which is CO3. It's how acid and pH work in the natural environment. And none of my classmates liked that, but I loved it. And so that was an indicator of, hey, here's maybe a different area you could focus within civil engineering that's more the chemistry and microbiology side.
Which then leads into
then leads into water quality and all of that. And that really teed up the rest of where we are and actually where we are here with INFRA as well.
Yeah.
In terms of water quality and water volume availability in the environment as a whole.
No, that's awesome. Okay. Thank you for explaining that, because it gets a little confusing.
It can be
for the non-engineers in the room.
It can be confusing.
Yeah. So now you're infra. What kinds of stuff? I mean, you work in water. I mean, what kinds of like projects you work on day to day? I mean, we work close in proximity, geographically wise. I mean, I see you on meetings all the time. But like, what's happening on a day to day basis? What kinds of projects are you guys looking at or working on and trying to solve?
Yeah, great question. At INFRA, we're really trying to wade into a new space that's emerged given the demands on the power grid and the water grid associated with AI.
Yeah.
And also reshoring of American industry. It's a role that we're pushing into that's really a new role on the block. So historically, you've got traditional design consulting, which is what I did early on in my career, same with our founder, Kyle, as well as a number of our staff. We all have this infrastructure design background associated with some form of civil or mechanical engineering. That scope of work that you write for a client to do detailed design engineering is very specific. You have to know exactly what you're designing. You have to know what the design criteria are. Probably there was a planning study that you wrote earlier on that laid all that out. And even then, the scope is fairly clear. I mean, historically, utilities both on the power and water side are planning for, since 1960s, are planning for a 3% growth year over year. You just map to population, you project that out, and you implement an infrastructure plan to upgrade that.
Yeah.
And then you hire a consulting engineer to go design those incremental improvements. When you have something like a data center come in and ask for 8 MGD of water, 8 million gallons a day of water, as an example, as a hypothetical, that's an order of magnitude potentially sometimes higher than the next 10-year plan that they had on file.
Yeah.
And so there's a whole new approach that needs to happen. And the scope of work that a traditional consulting engineer would write isn't necessarily applicable. So that's really where infra steps in with our model. And so what we're doing day to day is helping site developers, so hyperscale data center clients, large scale manufacturing, automotive, anything with a large power and water footprint. We help facilitate that overall solution and essentially rewrite the playbook to implement. And then we go help hire a more traditional design firm to execute that approach.
Okay. So you guys are kind of big picture. Companies or firms will come to you, or governmental organizations come to you guys with, hey, this is kind of what we're looking at. This is what we're being asked to do. And they come to you guys with, how do we go about that? Suggestions. And then so you guys look at it and say, okay, if I'm going to look at this is kind of what you had going on in the past. This is what you want to do. Here's kind of how we think you should do that. And then you guys help them connect with somebody else to then do the stuff.
Yeah, that's right.
Yeah.
So we're representing the site developer.
Yeah. So it's really like a specialized consulting firm.
Yeah, to specialize in a sense.
Yeah, and very specialized.
and kind of what the space we're marketing toward is what we call staff adjacent contracting, which is really where we like to embed within our clients' organizations to the degree possible to really understand what their portfolio goals are for infrastructure expansion, both on the power side, water, wastewater, transportation, even fiber. And we help stand up those initiatives and execute on delivering offsite infrastructure for those projects.
Gotcha.
And that's really where the overall strategy comes in.
Yeah. Have you guys been seeing, I don't know if exponential increase would be the correct word, but I guess a significant increase in business, given that a lot of companies are, moving towards onshoring and moving a lot of business and manufacturing back into the United States. Have you guys seen an increased need for your guys' firm's needs?
That's our business proposition.
Yeah.
And so I'd like to say, yeah, we do see a need for it. And there are plenty of published numbers out there. They're pretty astronomical. One figure is 140 gigawatts additional nationwide by 2030.
Wow.
Which is a lot. Just for frame of reference, the annual output of Grand Coulee Dam, which we associate as being one of the largest power production facilities in the nation, the annual output is about 2.3 gigawatts. The nameplate capacity is 6 gigawatts or 6,000 megawatts.
Yeah.
And so we're talking large scale power generation deployment to meet the demands of AI and reshoring. So that's the paradigmatic difference that's happening right now.
Yeah. Wow. That's crazy. That's like in the numbers in my head, I'm like trying to even quantify that. And it's just like very, very difficult, but it's good for you guys. Like
it's
everyone's
basically
how the heck were you supposed to do this?
Yeah. It's 20 to 30 Grand Coulee dams.
Yeah.
And so how do you piece together those infrastructure solutions? The analog on the water side, which is really my area of focus.
Yeah.
The infrastructure in our country is about typically 50 to 80 years old. So 52% of manufacturing sites are anywhere from 30 to 60 years old in our country. Some of them are older than that.
Yeah.
So another 20% are older than 50 years. And similarly, on the water infrastructure side, a lot of that infrastructure was originally built out post-World War II and also during World War II to meet high water demands. That's when we tapped into new resources. That's when we built new reservoirs. That's when we built large-scale pipelines. Those have essentially run their useful life. And so now you have the two-pronged issue of improving the existing infrastructure, which is at its useful life, combined with an overall increase in demand for water in the country.
Yeah. And crystal ball, you're looking at it. What do you think is the solution to that? How are you guys approaching that in terms of, near term and in the projects you're working on now, but then kind of preparing for the next, 10, 20, 50 years to where all this demand is probably going to be even higher?
Yeah, so that's a really complicated question.
Yeah.
And that's actually what we spend most of our time thinking about.
Yeah.
The interesting thing, I think, mainly from the water perspective, but also from a power generation perspective, is to augment the supply of water and power today is a very different enterprise than it was pre and during World War II. And actually, one of the main spaces that we operate in is applying a sustainability framework that actually encourages business value by sustainability. But it's predicated, that whole idea of sustainable business is predicated on the fact that a much larger group of people are aware of and care about the long-term viability of a project.
Yeah.
Both from a water use perspective, a water quality perspective, a power use and carbon emissions perspective, you name it. Environmental concerns are now ubiquitous in terms of people's understanding.
Yeah.
And the flow of information is democratized with social media and the internet. And this is, in my view, mainly a good thing. It's a good thing that everybody knows what the impacts of projects are going to be. So the challenge on the table for executing reshoring and the AI revolution in the United States is developing projects with an actual sustainability imprint that truly offsets water use and truly offsets carbon or truly offsets wastewater and water quality issues so that the net benefit for society truly is positive.
Yeah.
And that balance is going to be evident to a lot of people. And so the trick is putting together a water project that includes replenishment opportunities. That's a particular space of infra science and engineering that we operate, where we help develop water replenishment opportunities where you put together a water solution that gets water to a site, but then around that site, within the region, within the watershed, you identify projects that actually return drops of water into the environment that offset that water usage.
Okay.
And there's a whole market for it. This is not government regulated, and that's the really fascinating part.
Yeah.
Companies want to have an imprint that makes sense for the people in that area and for the environment in that area. And so they are motivated as a business value proposition to implement replenishment opportunities.
Interesting. Because I think when most people think of sustainability and business, those two usually don't mesh well. When people usually think of big business and especially manufacturing, I feel like a lot of people would assume that they're just going to do whatever is best for the business. And they're not really caring about environmental impact or whatever. And obviously there have been, laws passed to kind of make it more business friendly and more, incentivize the business to kind of care about that more. But that is interesting that beyond the, maybe tax implications or governmental oversight, there's still some, want to benefit the site and the community and all of that. That's very interesting.
Yeah, it's a whole emerging field of study and called sustainable business. So Bruce Howard was the director of environmental affairs at Avista for a long time. Great guy. He now teaches a class at Gonzaga called Sustainable Business. And I asked him, well, does sustainable business refer to implementing business operational practices that make a business viable long term? Or is that specifically with reference to its environmental imprint?
Yeah.
And he said, that's a great question. Nobody really agrees because the two are actually so intertwined now in ways that they weren't in the previous phase of industrial development in the country.
Yeah.
And so given that business sustainability and environmental stewardship are so intertwined now in a way that they weren't before, it opens up a whole lot of market solutions that are specifically impactful within a locale that really a sort of centralized compliance framework just wouldn't produce.
Yeah, that's awesome. When you're working with these businesses and you're, discussing not only the project at large, but then the environmental impact and sustainability of all of that, how do you recommend or consult on the, short-term, hey, this is the project we have in our hands right now versus the long-term effect of, hey, this is probably going to be here for 50 to 80 years. What is the sustainability impact going to look like then versus now? And how do you guys kind of differentiate that?
That's a great question. Part of it is phasing. So one of the main things we do in our staff adjacent contracting role with some of our large scale clients is help stand up infrastructural solutions that are phased based on project need. This is especially important as we're trying to bring back legacy industries, which is an area I'm super passionate about. I love reindustrialization.
Yeah.
So part of that is figuring out how does that phase day one versus long term. And so we do a lot of work to figure that out with our client organizations. In terms of how the project looks 30, 40, 50 years down the road, that's a very relevant question because actually these facilities, data centers, steel facilities, even brownfield facilities that they're bringing back online have a very long lifetime. For capital allocators, that's very difficult because capital funds, venture funds are trying to gauge what the payback timeframe is going to be. And for a lot of these heavy infrastructure industries, it's a much longer timescale.
Yeah.
So the questions about how it impacts, say, a groundwater system, that's a 50-year question. So we actually have pioneered a water risk framework. And it aligns somewhat with the Water Resource Institute volumetric accounting, where it's ways of tabulating water flow. But the question on the table from the get-go is, if we implement a groundwater withdrawal system, say, for the next 50 years, is that going to contribute to groundwater subsidence? Subsidence is the process whereby we suck more groundwater out of the aquifer than comes into